All right, everyone. Thank you for joining us today. We have an amazing speaker, Aditi Saluja. She is going to take it away in just a moment. So without any further ado, Aditi, if you could turn on your camera and say hello to everyone.
Hey, everyone.
All right, it's all you now. I'll be here if you need anything. Give me a holler.
Sure. Hey, everyone. This is Aditi Saluja. Thanks for joining the session today. I'm a senior data scientist at T-Mobile. I lead and drive the delivery of highly scalable machine learning solutions. I'm also an in-house trainer in machine learning and distributed computing using Spark. The topic of my talk today is a look at a customer journey. And let me start by sharing my screen. Today, I'm going to walk you through the following content. The first thing that I'm going to walk you through is going to be the problem statement opportunities, network related complaint scenarios, data exploration and challenges, approach to overcome the challenges, feature engineering, model explanation, key indicators to identify model performance, and actions. The problem here is bifold. The first part of the problem is to deliver and develop an algorithm to predict if a customer will file a network complaint in the next 7 days or not. And the second part of the problem is to reduce churn. Reduce churn by finding the customers with similar patterns, because it's seen that the customers often churn without filing the network complaint. So basically, based on the first scenario, based on the people who are filing the complaint, we are going to check the patterns and see the people who are not going to file the complaint and who are likely to churn. These are the following opportunities that comes with this project. Well, customer satisfaction is the key to T-Mobile, and this project is going to help satisfy the customer because now they will have very engaging conversations. The care agent will know their problem beforehand. The second opportunity that comes with this project is saving the manual resources. We will be saving the calls to care, the number of calls to care, and at the same time, the duration of the call, because now the care agent is aware about the issues that the customer is going to potentially face. The third opportunity that comes is early detection. We'll know a little ahead of time that this problem is going to occur. And because we have some time, now we will have more time to take care of the issues. We will be proactively troubleshooting the problem because, as I told earlier, we have a little more time. We don't have to follow the reactive approach anymore. We will also have an opportunity to reduce the churn and to prevent the churn, because now we have an idea of the pattern. Now we know the customers who are likely to churn and the customers who are facing the network issues. These are some of the network complaint scenarios. We have often seen that people make a complaint because of the drop calls, because of the device related issues. And when I'm saying device related issues, I mean a customer might have changed the mobile phone, and right after they are changing the mobile phone, they might face some issues because of the version changes in the mobile phone, in the devices, or if they are using very old devices, they might still have some kind of issues. The other issue that's seen is, the other network complaint reason that's seen is network unavailability. If the network is not available, then a customer is likely to complain. Poor quality of connection, failure to connect. Failure to connect is when the customer is trying to call and he is not able to call to anyone, then that's failure to connect. That means he is trying to reconnect the call. Another reason for the network complaint is low throughput. Low throughput is low internet speed. It's seen that if people are not getting good internet speed, they are likely to open a complaint. Here's the flowchart of the project that I have worked on. The first part of the project was to collect the network event data from multiple data sources. There was not just one data source, there were multiple data sources, and there was multi-terabytes of data that was processed to be able to achieve this solution. Then after collecting the data and after cleansing the data, which was of course removing nulls, outliers, and certain other things, of course, we also had some formulas to be able to identify what could be the network related concerns, and we created the KPIs on top of it. Once the cleansing was done, we were continuously running a path analytic job. Now this path analytic job worked for us as a filter because we didn't want to classify all the customers. We necessarily have to have a filter conditions to be able to identify which customers are likely to open the ticket. And then once we did that filter criteria, and I'm going to show it to you in the next slides. Once we did this filtering, we ran a CNN model. And then by using the CNN model, I was able to classify if a customer is likely to open a complaint ticket or not. Once it was identified, then based on the conditions and based on the scenarios, the information was sent to the customer care team, the information is sent to the network optimization team, and the information is sent to the marketing and messaging team. In the data engineering, I aggregated the data at an hourly level. So once the KPIs were created, once we knew what was the threshold of any particular KPI to be defined as a bad performer, the data was aggregated, and the data was aggregated at hourly level. So let's say if an event is happening once in 1 hour, then it will sum up to 1. If the event is happening 5 times in an hour, then it will be 5. And if there's no event happening, then that particular KPI will remain 0 for that particular hour. It started with the 50 million subscribers. Now, as you can see in the plot, in the data exploration plot, in the bar chart, as you can see, there are 2 things happening here, which are going to fetch your attention. If you see Y, and when you see X, you will see that there's a little imbalance in the data. Y is very small number because Y is happening very few times. Y is my dependent variable, which is opening a complaint ticket. The another thing that's happening here is, if you can see in the plot, X1 is twice double than the second largest variable. So that means the X1 is overpowering all the other attributes. And if it keeps on happening, if this is how I feed my model, then my model is going to be a little biased towards X1. And this is something that I don't really want. Well, these are the approaches that I took to overcome those challenges. The first thing that I did was to use the smooth package to oversample my rare class. Well, smooth package uses the nearest neighbor to oversample the data. Once the data was oversampled, then the other challenge was X1 was overpowering all the other attributes. Now, because I'm an SME in the telecom industry, I know one thing, that X1 is an attribute which is not as obvious as other attributes. Like there is one attribute, drop call, which is very obvious to the customers, but X1 is not that obvious to the customer. Also, X1 is a situation which will happen if a customer is at one location for quite a while. So let's say if one customer is at a certain location, if he is in the office for 3 hours, then it is very likely that X1 will remain as it is for the 3 hours. So basically, based on some hit and try and based on the subject matter expertise, I was able to identify the solution of this problem. Well, I grouped three consecutive ones. So three consecutive events in the hours, I grouped them and I considered them as one. I'll give you an example. So let's say if X1 is happening at hour 2, at hour 3, at hour 4, then I will not consider it as three events. I'm going to consider it as one event. If X1 is happening consecutively for 4 hours, then I will consider it as two events. Three consecutive is going to be one, and the fourth event is going to be the another event. After cleansing the data and after taking care of those challenges, those two biggest challenges, I did some path analysis. Well, here, as you can see in this path analysis, there are three paths which the customers are following before they are calling to the care. Why is calling to the care and filing a complaint? So here, the broadest path, which is X4, X3, and X10, it is leading the customer to call to care. Then there's another path, which is X3, X4, and X2. This is also the path which is leading the customer to call to care. And the third path, which is not that broad, which is X1 and X12, it is also leading the customer to file a complaint. Well, it worked to me as a filter criteria because initially I was working with 50 million subscribers and it was a huge amount of data to be processed. Based on this path analytics, which is continuously running in the backend, I filtered out the rest of the customers. Now I'm approaching towards my model building. And before I'll build my model, I'm splitting the data into train and test. Initially, the data was 90 days worth, and then I'm splitting the data into training data and testing data. The testing data is for 59 days, and the test data is for 21 days. The training data is further split into positive levels and negative levels. As I mentioned earlier, that the data is very much imbalanced. So basically, my negative class is greater than 99%, and my positive class is less than 1%. My positive class is the people who are opening the ticket, and my negative class is the people who are not opening the ticket. By using Smart PK package, I oversampled the positive class. And once the data was balanced, I trained my model. As you can see in the plot, I didn't make any changes in the test data because I didn't want to create any noise and it wouldn't give me the right results if I'll balance my test data as well. Now, this is how I did the feature engineering. And when I'm doing the feature engineering, I'm doing this feature engineering only on the training data. In my training data, the first 7 days are the features and the last 7 days are the labels. So basically, I'm having 14 days of window. The first 7 days of that 14 days are the features. The next 7 days of those 14 days are the labels. Based on the customer pattern, based on the network pattern of the customers, I'm training my model for first 7 days. And then I'm identifying in the next 7 days if a customer is going to open a ticket or not. And I'm using the 7 days criteria because we have often seen, and not only we have seen, we have done some pattern analysis also to validate this hypothesis that if there is any network issue, then the customer will make a complaint in the 7 days, in the next 7 days. Customer is not going to wait for 1 month or 2 months to file a complaint if there is any network related issues. So that's the reason why I'm looking at first 7 days, trying to understand the behavior of the customer, training my model for the first 7 days, and then making a prediction if a customer is going to call in the next 7 days or not. Then I'm moving this window. This window moves 1 day per step. Now my first 7 days will become from D1 to D7, and my label will be D8 to D14. My third window is going to be D2 to D8, and then the label is going to be D9 to D15. And this is how the windows will keep shifting one day, one step. And it will be shifted until the final day is reached. Once the entire feature engineering is done, then I'm actually changing the format of my data. Now my attributes are the days, and my rows, my records are the KPIs, are the dimensions, the aggregated dimensions that I was using. So here D0 to D59 is going to be my time limit dimension, and X1 to X14 is going to be my rows. And now there's one thing you should notice is X1 to X14, the first X1 to X14 is going to be just for one subscriber. For the next subscriber, the record is going to be from X15 to X28, and so and so. And the reason why I'm using this is because if I had not used it, if I was having all the attributes, all the time dimensions, and all the KPIs as the attributes, then for X1, I would be having 59 dimensions. For X2, I would be having further 59 dimensions, and that means a lot of dimensions. To be able to simplify my data set, I actually changed my data into 2D image format. Then on top of it, I applied convolutional neural network. It is a very simple convolutional neural network, and it worked really well on my data. The first layer, which is the convolution layer, it acts as a filter, which helps to reduce the information, but it captures the important ones. Then the second layer is the pooling layer. Here I'm using max pooling. The pooling layer takes care of capturing the information from different angles. So not only it is looking at the sequence as to when the person is going to file a complaint, it is also looking at it from different dimensions, from multiple dimensions. So let's say if X3 event happened after X4 event, and then the customer is going to call a complaint, it will look at that event for sure. It will also look at that event from the different direction, X4 followed by X3 as well as X3 followed by X4. It will look at all the things. One more thing that pooling is doing is it is avoiding overfitting in my data. Once pooling is done, then I am fully connecting my CNN model. And then I'm applying the sigmoid function to be able to identify the probability that if a customer is likely to churn or not. Here are some key indicators that I used to identify the model performance. First was ROC and AOC. Well, by default, the cutoff for every model is 0.5. So let's say if the probability of a customer to churn is greater than 0.5, then as per the model, the customer will churn. This is the default cutoff. And if the probability is less than 0.5, then the model says the customer is not likely to jump. But based on the ROC and AUC that I was drawing, it seems that for me, it was occurrent that I would have to change my cutoff range based on the business needs, because my business was more interested in capturing the customers who are going to open the network tickets. So I had to use ROC and AUC to be able to identify the best model and to be able to identify the best cutoff range. The second metric that was really important for this particular exercise was recall. Recall is to identify the percentage of correctly classified open tickets. In my case, accuracy was not important, and the reason being, 99% of the people are not opening a ticket. Only 1% of the people is opening a ticket. So if I would not even build a model, then also the accuracy of my model is going to be 99%. So accuracy was not a good metric for me. However, recall was really important because recall is giving me the result only for the correctly classified open tickets. The third metric that was important for me was the precision. It gives the information about the performance with respect to false positives, because recalls sometimes come with a cost. That's the reason why I had to look at precision as well, to be able to identify if I'm not capturing a lot of false positives in my model. The actions that we did after building the entire model were used in 3 different aspects. The first was we were helping the customer care team to be more informed. Now the care team has more information to be able to interact with the customer. They know a little ahead of time that a customer is going to call to care or not. They know the network related issues that the customer is likely to have. The second aspect of this particular problem where it is helpful is with the network team. If a fault is about to happen, if there's a potential probability of a fault to be incurred in any particular area, then the network team has an opportunity to optimize and to plan the capacity in that particular area. Before the customer would file the complaint, before the group of customers will file a complaint, the capacity planning team can help in improving the capacity of that particular cell tower, or they can build another cell tower, and they can do multiple things based on the capacity strategy. Another advantage of doing this particular modeling exercise was with the marketing team, because now marketing team has the information about the customers who can potentially churn because of the network reasons. Now this enables the marketing team to send relevant message to the high churn propensity customers. They can, now they have the option of sending them some offers. Now they have the option to call them and to see if they need some kind of upgrades, or if there's something else they should be doing.
2-minute warning.
Well, this is it about my presentation today. I hope you guys enjoyed it, and thank you so much for joining me.
Wow, great timing. Thank you so much. A big virtual round of applause for Aditi, everyone. Thank you very much. Everyone stick around and don't go anywhere. We have more content coming. Thank you.